Okay. Hey everyone. Hey Jed. Okay. Did I ever see your geometry illustration for the geometry and math homework? I saw that you posted it, but the problem looked like a competition problem, so I was kind of ignoring it. I'm gonna be honest. I'll take a look at it now though if you want to talk about it. It's it looks like a competition. Like the question looks like it's a competition question. So I just wasn't that interested. Hey Henrik. How are you doing? So P and Q are opposite corners. I just need to see your. I'm not going to try to visualize this. Variable point on segment PQ. Dude, yeah. There's so much happening in the question too. That's why I didn't try with it. Decoder label, yeah. So let's just see what you did then. As X, show that M moves along a circle, and it's the midpoint of ST. I'm doing good. Thanks for asking. Oh my god. Okay. Uh, APBQ is the quadrilateral we start with. So APBQ, P and Q are 90 degrees. AP equals AQ, and they're both less than BP. Okay, so we get that like kite looking thing. Let X be a variable point on segment PQ. PQ. Hey Anand, let me just reread the question first and match what I'm seeing in the question to the image, and then we can talk. I won't be doing the actual reading group. I might do some questions out of the book for fun. I haven't decided yet though. Do you have a preference? So if you're interested in seeing that, I can definitely do one if there's some downtime here. AX meets omega again at S. AX, okay, meets omega at S. Point T lies on arc AQB. Arc AQB such that XT is perpendicular to AX. Okay. Let M denote the midpoint of chord ST. As X varies on segment PQ, show that M moves along a circle. As X varies on segment PQ, show that M moves in a circle. Wow. That's... Yeah, I'll hop in Discord and talk with you about it, Jed, but like, yeah. Hey, Jed.
Yeah, I had to stop it there. I had no clue how to go beyond that, but I got the
Okay.
diagram working and properly labeled and notated.
Yeah, it definitely seems accurate to me too.
My comments there also, you can move A, because it's basically just restricted to the x-axis to make the image bigger or smaller as you want. You can move P, and it's going to also move Q because P and Q both have to be 90 degrees, and AP and AQ have to be the same. So if you move P, basically you keep it right on the y-axis, and you maintain that less than BP requirement. Because
Okay, yeah.
if it's on the y-axis, then AP is equal to BP.
Yeah.
But if it's to the right of the y-axis, then so you can adjust kind of the length of that PQ segment that you have to drag X along, which does affect M. So in any of those cases, basically you just got that's it. I haven't done anything as far as trying to figure out where the center of that circle that M is traveling along. I don't understand that part of it yet.
Yeah.
But I thought maybe the illustration could be helpful for somebody to come back and say, oh yeah, well here's why you've got, whatever. Whether there's this relationship between X and M in the center of that circle or what, I don't know.
Yeah, like I bet there's gonna be some, vague theorem that I'd never heard of that does the trick for you to this situation, but I sure don't know it.
Just I hadn't seen any responses on that. And
That's
it's
fair. Yeah.
over a week old. So I just want to see if my illustration was helpful for anybody or if there's something you're just kind of sweeping under the rug, so to speak.
I mean, there's a couple that I have swept under the rug. Or at least I don't have plans on trying to respond to them. 'Cause I just don't think I don't even know where to start. But
Yeah, like the one with the determine the integers n greater than 1 such that every power of n has an odd number of digits. That one
yeah,
was kind of
that one I
I
think was
don't know
just
what to
for
make
fun
of
as
that one.
well. So I don't think the
Well, I
person
mean,
actually needed help.
I guess was 100 a valid answer? Because
Oh,
n to the 0, 100 to the 0th would be 1, which is 1 digit. And then every time you multiply another 100, you get 2 more digits attached to it, so it would always be odd. And similarly, I guess 10,000 would fit, and a million, not a million. If you did 100, you did 10,000, and yeah, I guess a million would work because it's an you're always adding an even number of digits, and it's never going to.
yeah.
So I'm guessing any 10 to the nth power where n is even.
And the person did put the 100 emoji there. I thought it was just for fun, but that seems like a hint now.
Yeah, maybe, I don't know. So
Huh. That's
but
probably
that's the
I
only thing
can't
I can
imagine
come up with
any other number would have that.
because eventually, if you use something like 101, eventually that one extra is going to cause it to overflow and get to an even number of digits.
Hmm.
But that was my first take on this. Like, okay, well, what's the, it can't be anything less than 100, because then to the first power, it's an even number of digits, so it can't be less than 100. So it has to be more than 100,
Oh yeah,
right?
yeah. That's a nice way of like figuring that piece out quickly.
So, anyways, I thought that was kind of a fun little geometric illustration and the power of GeoGebra.
Yeah, that is a really neat like visualization that you can make there.
Yeah, that's all I had. Again, I don't have any like significant knowledge. I guess X and M kind of all converge on Q, right?
Uh oh yeah, as you drag, they do get closer together.
Yeah, I don't know if they all converge to the same point, but I guess if S and T both become Q,
I bet you have to
then the
make.
midpoint of that would be Q.
Uh,
I'm
wait,
not
when does
sure how
Q become the midpoint? Oh, I see. If you make M go on
when
there.
T
Okay.
like T goes past Q and then if you keep going, it comes back to Q, and S continues to approach Q until the point, Q equals T equals X equals F equals M. So that's a point on the circle, but this and then eventually ST aligns with BP. So the midpoint of BP is on the circle.
Mm-hmm.
So I don't know if. So I guess if you consider the midpoint of BP and Q as being, it's not a diameter necessarily, I don't think,
No.
of the circle, because it does seem to move. It's not a uniform movement between them. It's like, I don't know if it's So I don't know if there's some kind of relationship there that I'm just not familiar with geometrically.
I'm sure there is, because there's always just the most vague theorems, but
Yeah,
um,
something will make it work, but it's just a matter of trying to figure out what that is.
yeah. Hey, Bode.
Anyways,
All
that's it.
right.
I'll
Thank
let
you
you
for talking.
continue back to whatever you had planned.
Sounds good. All right.
All right,
See ya.
bye.
Okay. Um. So Henrik, you asked, I'm having difficulty understanding different types of transistors and why they are useful. Hmm. We've only barely talked about transistors. It's pretty theoretical. Like we haven't really talked much about Oh yeah, it was posted in my Discord 9 days ago in that homework help forum. Jed made that visualization. It's it's all the oh okay. I mean, if you happen to like, would I be able to find a solution online and just like post it for this person? Because I was kind of ignoring the thread here because I definitely don't know how to do it. But if you happen to know like what year it is, probably on AOPS. Okay, I might see if I can just at least find a solution for him and post it then. Um, yeah, for the transistors thing, Henrik, I wonder if Benbox would happen to know that offhand, if he ever pops in chat. But hey RBA, yeah, well, long time. How have you been? Or Mary? Oh, he streams in a bad time zone for you though. Meriwether or Mark probably would know. I'll shout him out in case you do happen to be able to catch him. But Meriwether Mark is an actual like electrical engineer who can probably speak to the applications a lot more. See what the question we got? Oh yeah. But yeah, I haven't studied transistors at all besides looking at like a very like theoretical basic type of transistor, I think, as part of a problem. Feel free to post it there in chat, or if you're in the Discord, post it in there. Trying to think, is there anyone else who knows circuits? I can't think of one. Yeah, sorry. Oh god, I don't even know the answer to that. It's uh I can Google it. I definitely I don't even know what a relay is. That's how bad I am. Yeah, okay. I don't even know where to start with this. I'm sorry. And I'm sure you know how to Google stuff yourself too, so I don't know if this is even going to be a helpful thing for me to do. Let me look at RBA's problem. Also, this is going to be a thing on the stream now for a little bit. If there is downtime. Uh, RBA, let me rotate that. Nice. Are you asking for help with all these? Or like which one? This coffee tastes like shit, man. I mean, it's not bad, but it's like, it just tastes really generic. Just the second one? Okay. Need to deduct from the first one. Okay. To solve the limits. Okay, so... What the hell? Okay. And so you have 3 different limits to figure out, and we have number 1 to help us out with that, presumably. So if x is greater than 0, arctan x plus arctan 1 over x. Oh, okay. Well, maybe. Let's think about this. Oh, Henrik, that's they're doing an event for streamers where you could apply and get to play the map early in like a streamer only server. It's really annoying for me because you need 1,000 follow. I tried. You need 1,000 followers to apply, and I have 987. So the application just told me no. They said you can DM the Daisy Twitter account and ask for permission anyway. And so I tried that, and they got back to me, and they, in a polite way, said no, which is fair enough. It's their right, but it's really... I feel bummed about it. So it's happening for... This is the second week of it now, and the actual DLC is coming out, I think in a week exactly. But I think even if I had 1,000 followers, I'm probably not likely to get in. I feel like just having math in my name makes me unlikely to be accepted for something like that, which is, of course, you know, I chose my name, so I have to deal with that, but... So... Reaper, hey, Don does math Z. $47 equals... Thank you, Hardluck. Now, I'm actually thinking about just like changing my name because of that, but I haven't really like... Apparently every single username on Twitch is just taken, so I haven't been able to find a good one. So I'm not quite sure where to go with this RBA, but I'm just kind of... The only thing I see to do immediately is to split this up into... Even then, that's not all that helpful. Like, I see that we can split the fraction inside there into 1 over x plus x. But this isn't... Like, this is arctan x plus arctan 1 over x. And so we just don't have that situation here. Which I think we need to maybe go to the trig identities. Because there is an identity involving arctan. It's not on this sheet though. Arctan identities. Oh, wait. I think it's a rearrangement. I mean, we can just use the result of the first question, I think, but... Okay. I think there's some way you can mess with this identity right here to make it work for arctans. But actually, maybe... You tried it... Oh, for... You just want to... Oh, thank you, Bode. I appreciate you finding that. Like, we can just think about the first question first if you want. I've seen a problem, like, really similar to this, and I'm trying to remember, like, what we did. You're gonna do your homework now? Alright, sounds good, Bode. Hope your homework goes well. Okay, so what happens if we just plug infinity in? We get infinity times arctan of infinity, which is pi over 2. So, okay, I mean, this seems to diverge. Because isn't... Maybe we... For this first one, we don't even need the top... Wait. I'm going to graph this first function. I think it just goes to infinity. No, I'm wrong. That's not the first time that I'm wrong. Make sure I copied it down right. It goes to -2. Why would it do that? As arctan goes out to infinity, it goes to pi over 2. And when that thing inside parentheses goes to infinity, it's going to blow out to infinity. Or sorry, it's... Wait, what? This graph makes no sense to me. I must be missing something. What does Wolfram Alpha think of this limit? My intuition here is not right, apparently. How is that possible? Oh, because the X gets to... I get it. Okay. It's because, in the long run, the arctan hardly makes a difference, but you end up with X times arctan X minus pi X, so it's like you get two linear things subtracted from each other. Okay, so that... Now I have the intuition for why this thing looks like it does, but why... We would basically infinity minus infinity and have to deal with that, and that's the indeterminate form that I'm assuming you're talking about RBA. So yeah, how do we deal with that? That's not an easy limit. It's a good question. Hmm. Okay, so what if we factor the 2 out as well? Because this gives us a pi over 2, which matches, we're going to infinity, so we could theoretically do something with this formula here. So like, if this is this x here, we should know that arctan 1 plus x squared over x plus arctan, the reciprocal of this thing, is equal to pi over 2. And we could rearrange this formula here to match the situation at hand. So we would get arctan. Oh, I shouldn't do an equal sign there. That's bad form. Minus pi over 2 equals minus arctan x over 1 plus x squared. Because I subtract the pi over 2 over, and I subtract the arctan over. What the heck is a gigolo? I should ask the Insane Clown Posse. I heard they know. Oh wait, no, that's a juggalo. Never mind. I'm sorry. I'm getting mixed up with the songs. Never mind. A gigolo is a young man who is paid to go on dates and or have sex with older women. And by young, I mean like 20s. Or is a jiggle something else? I see that's a typo for gigolo. I don't know, dude. Dang, you can't be one. You know, Harlock, don't let your dreams be dreams. I still believe in you. So we can use this formula up here. 2x. Oh, what a terrible x. I mean, I'm sure those 80-year-old women like can't tell the difference. Hardlocked. You should just go for it. Does this help us? We can L'Hopital's this now, I think. Maybe? Because, this is 0, this is infinity. You can post a video, yeah. I probably won't like watch it right now, but we can't use Lopitals? I swear we did a Lopitals problem with you a while ago, but maybe if you can't use it here, it's out of our program? No. Okay. Well, what the hell then? How else could we deal with this? Okay. I want to work on this problem right now, but maybe I'll watch it like off stream or something. This feels like what we're supposed to do, but I don't see... I don't see how we do this without Lopitals. If I give a map of this form of the limit, is it going to have a better idea? Because I really... Okay, yeah, sure, Wolfram. That's not the part that I'm confused about. Yeah, okay, Wolfram is using Lopitals. Okay, I mean, it's saying, like, it's saying to deduce? Is that what... I'm not even trying to pronounce that word. Is that what that means? I wonder if they don't want you to prove it, but they just want you to kind of explain it, like, intuitively? So I don't see how it's possible without Lopitals. Because what I'd say is that we have basically x, and we have arctan x over 1 plus x squared being multiplied. Oop. I'm cooked. Like, oh no, we're going to infinity. I don't know how you deduce this, I guess. This is... Like, could you use the power series for arctan? Is that allowed? Curious what it would look like. I don't know if this actually helps. This is only valid between -1 and 1. This doesn't help. Okay, I don't know what to do with this limit if we can't use L'Hopital's then. We could at least try to... Maybe the other ones I'll be able to find a way. Lucas, if you want to put your question in there now, if it's a shorter one, I might just like quickly try and address it. It's a translation? Okay, it's good to know. What's happening with this function if we try to plug in 0 from the right? This is going to be pi over 2. Times -1. So we get a finite number on top, I think, divided by 0, but there's no way it's going to diverge again. Or there's no way, like, my intuition here must still be wrong. Whoa. Okay, it's a funky looking function. Lucas, I think there's... Well... I'm gonna have to think about that more, Lucas. Yeah, it might not be a short question. Alright, well, from the above, we know that arctan 1 over x is equal to, subtract the arctan x over, oops, pi over 2 minus arctan x. It's a question in your last test. Is it a calculus class? You don't know what calculus is, so maybe? Or like, what? Oh, it might be hard to translate, I guess. Do you know the word for what class you're in? Or if not, it's okay, but... 16. Okay, so you might be in like geometry or algebra or pre-calc then. I said America, there's a pretty big range of options, but it's something around that level usually, I think. Um, I'm just playing around with function right now. I don't know if any of this is actually going to be helpful that I'm doing right now. You haven't learned matrices yet. Okay. Yeah, I wouldn't think of to use a matrix in that situation anyway. This is annoying. I don't think I did a helpful sub here. I don't know what other sub you could possibly do though. I don't know. I'm sorry, man. It's just a difficult question. It's probably comparable to A level toms. This is from RBA there in the YouTube chat. We're working on number 2 here. And we had apparently the identity from number 1 is going to be helpful. And this word right here is deduct. So I figured out a way to do this first limit, but it involves using L'Hopitals. And we're apparently not allowed to use L'Hopitals. Beyond this kind of stuff in a year. Oh, okay. Good luck, I guess. I've seen some A level for further math problems, and I can do them, but they're definitely tricky. A level further maths in 2026 summer. Wow. I'll Google the problem itself, but I might be out of ideas. Like there must be some type of trick that we can use here that I'm just not seeing. It's like a similar problem. Oh, it's the exact same. That's L'Hopital's. Show me a different one. Whoa, whoa, whoa. This looks like what we want. Sure, Lucas, yeah. Thanks for being patient. Is this what we want? Let me put my mug away. I don't know, Spectre. It's apparently just not included in this person's class. I'll be back in just 1 second. Okay, I think what they're doing is they're noticing the limit matches the limit definition of a derivative from here or from here. I think I like the first one more, though. Let's make some room. I make it easy and it's also... Yeah, exactly. So... Wow. Okay, you know, let's just get rid of all this garbage. So we're taking x equals to 1 over t. Change of variables. So that means that when x goes to infinity, t goes to 0 from the right. And this becomes 2 times 1 over t. This thing's annoying. 1 plus x squared over x equals 1 plus 1 over t squared over 1 over t, which becomes t plus 1 over t? That's also... What? Wow, that does not look like 1 over t. That's kind of crazy. How does this person get... I don't see how this person gets just t's inside the argument. Oh, they have a different expression. Hey, Yasser. Okay, we have, I see. We have an x squared plus 1 over x. This person just has an x. Instagerm, this is we're working on a limit question from RBA. So we have to, that's probably a good approach. We have to modify it somehow to work for our situation. So what if we took t equals to that? We probably can't solve this for x, can we? Yeah, this is pretty tough. This is a really tough calculus question in Instagram. You're probably not going to encounter anything this tough on your first class. Can you explain what is functions and how to solve it? Can you give me an example of what you mean? That I'm not sure what you mean with that, yes, sir. A function is just any equation that maps each input to a unique output. Or sorry, that each input gets one output. So the thing that's commonly taught is like a function has to pass the vertical line test, so like a linear function like that. Any vertical line you draw should only hit the function once. So an example of something that's not a function, oops, is like this thing. This is not a function because it fails the vertical line test. It hits the function twice. Or, you know, you're able to draw a vertical line that hits it twice. That's the quick explanation, but I'd love to figure out. Sorry, because I'm also trying to figure out what's up with this limit question here. So I'm trying to juggle a couple things at once right now. Awesome. Glad to hear a yes, sir. If we actually stick with this, we could say 1 plus x squared over x is equal to 1 over x plus x, which is equal to 1 over t plus t. Does that help? I doubt it. No, what I really want here is a single variable inside the parentheses. But that messes up this x out in front. In 11th grade, what should I learn to get ahead in math? What math class are you in right now? Hey, Jayesh. So maths and further maths A level. Oh yeah, I start looking into the A levels then. Just like I think there's like previous exams that they posted. I just look into how to do those. You know, it's like one of the most helpful thing that you could do. Because like I'd say in general, like you probably want to start looking into like pre-calculus or calculus depending on your level. So a lot better to specifically look at like further maths A level stuff though. In general, a site that I do like a lot for like a crash course on calculus, it's not specific to the A levels, but I do like this site a lot. They cover basically everything calculus you would ever want to know, and they do a crash course on algebra and differential equation. Or I'm sorry, on like the algebra that you need to know to do calculus. So it's a little resource right there. Yeah, JJ, I remember the integration king. Hey, Lucas. All right, so yeah, let's talk about your question, Lucas. So RBA, I'm gonna keep on thinking about this. I'll get back to you on Discord, or if you're still around on the stream later. I think the idea is you have to do some type of change of variable to get it so it matches the limit definition of a derivative. Oh, wait a second. Let me actually wait. One more thing before I look at Lucas's problem. What happens if we take the derivative of this, actually? Quotient rule. Low D high minus high D low. How does that clean up? Okay, this is an unhelpful train of thought, but my thought is that you need to make it match limit as x goes to 0 from the right. The limit like arctan 1 plus x squared over x minus. Well, this isn't. See, my notation is going to be bad here because I'm dividing by 0, but it's something like this where we have to like we want to get this for our limit somehow, or something like this. And actually, it's not going to be like it's going to be more something like just with an x there. And so this x might turn into a t, or it's going to make a t when we do a change of variables, but arctan x minus arctan 0, and arctan of 0 is just 0. So I don't. And then we know what the left side is because we know how to take the derivative of arctan, I hope. But I'm having a hard time coming from here to something that looks like a limit definition of a derivative. I think that's the key idea, though. Jash, I think the answer is -2 for this limit. The issue is we're not allowed to use L'Hopitals, so we have to do something weird. Like, we have to look for other ways, I guess. But I need to put a pin in this because Lucas asked a question a while ago, and I want to address it. Geometry? Not competition geometry. If it's geometry you like learn in school, then yeah. Okay, so Lucas wants to know, you want to make a cardboard box in shape of a beam with a square top and bottom surface. The volume is 1 cubic meter. How much cardboard do you need in square meters? And I feel like there's infinitely many answers for this question, but let's think about it. So let's say the square is side A, or is length A, and then the length of this thing is L. So the volume of a box like this is length times width times height, but in our case, the width and the height are the same, so it's just L times A squared. And we know that's equal to 1, because we have 1 cubic meter of volume. Now the surface area is going to be, we look at each of the faces and add up the areas. So we have 2 faces that are A by A, so we have 2A squared, plus we have 1, 2, 3, 4 faces that are A times L, so 4AL. Yeah, surface area is square meters. Oh, okay, I was looking for an identity like that. That might be the key there, JS. I'm not sure exactly how to use it up there, but it probably is something like that. And so the surface area is square meters, and we can check that by, we have a length times a length with A squared, so that's distance squared. Then we have a length times a length here, which is distance squared again. And up here we have 3 lengths multiplied, so that's cubic meters. Okay, so from the first equation, we know that L equals 1 over A squared if we divide the A over. What's up? What does SA equal save? By SA I mean surface area? Is that what you were asking? Or I guess more like, what is this part? Okay, so I got this part. How you get surface area is you look at each of the like sides of this box and you add up their areas. So this right here is a square with length A. So that's A squared. But we have another one back here. So I took A squared and multiplied it by 2. And that's the first piece. We have another one that and then we have 4 more rectangles that are, they have one length A and the other length L. So there's one there. That's area A times L. And then we have 4 more because we have the top, the back side, and the bottom. Um, See, if you're with me so far, or it's like, do you understand where this comes from now? Exactly that, yeah. So that works for any shape with flat sides. Lucas. Yeah, JH, the difficulty is apparently the person isn't allowed to use Lopitals. So I think you have to make it look like the limit definition of a derivative. I wish we could use Lopitals, so it would be a lot easier to find flats. We don't have to go that far, Jet. It works with a pyramid. You can add up the faces of a pyramid. But anyway. So how we deal with a problem like this is we know the volume is 1. We want to figure out surface area. So we're going to work with the thing we know and try to plug it into the thing we don't know. So I want to get this in terms of one variable, just so it's easier to work with. So I'm going to use our volume, the thing that we do know, and just isolate one variable. You don't, okay. So maybe you're familiar with this idea then. So only one of those 3 chapters back? Okay. So I took this equation and I divided both sides by a squared, just to isolate the L. And the idea behind, like, or now we know that L is 1 over a squared. And now I want to plug that in down here in surface area. So we get 2a squared plus 4a, and then the L becomes 1 over a squared now. And then this a can cancel with one of those a's. This isn't easy to work with, though. I was hoping we would get something that looks different. So, Lucas, you don't know what a derivative is, right? Like, if I said 2a squared plus 4 over a prime is equal to 4a minus 4 over a squared, you don't know how this works? No? Okay. Because this is a really common calculus question, but if you don't know how to do that, I don't know how you would do that. Are you allowed to graph it? Can you use a graphing calculator? Yes? Okay, that's how we do it then. We want the minimum surface area. I mean, yeah. It should just be that A equals L, but I think we need to prove that. Whoa. What is this function? 2a squared plus 4 over a. Okay. So thank you, Chad. if we're allowed to use a graphing calculator, it looks like we hit a minimum at 1,6. So, because we don't look at the left side of the graph because a negative length makes no sense. Okay, good. This is the minimum. Because we don't look at the left side of the graph because the negative length makes no sense, and so the right side of the graph is the surface area for any volume of A. So the y-axis is surface area, the x-axis is A. And so we just want to look at, because we want the minimum surface area, which is the minimum cardboard. We look at the minimum here. So when A equals 1, we have the minimum surface area, is how we read this graph. So, from graphing calculator, the minimum surface area happens when A equals 1. And so if A equals 1, that means L equals 1 over 1 squared, plugging back into this relationship here. And 1 over 1 squared is just 1. So we get kind of a boring answer, which is for a given volume, if you want to optimize surface area, you just make it a cube. Because both A and L are 1. The surface area is 6. So let me I'll do a crappy little copy of the graph here. The graph looks something like that. This axis was A. This axis was surface area. We want the minimum, we want to find the minimum surface area, but we're only interested in really the A value when that happens. So the minimum is right there at the point 1, 6. 6 is the surface area. A is the measurement. I am Anshuman from India. Do you remember me? I do remember you. You don't need to complain about a reply. Like, I am in the middle of explaining something. So, oh, I'm sorry. You're right. The minimum, okay. No, I misinterpreted what the actual question was. So they don't, the answer is 6. You're actually right. I'm sorry. I thought they were asking about the dimensions of the box, but they want the actual minimum surface area. So the final answer to this question is 6, because the question was, how much cardboard do you need? So you're correct there, Lucas. Is that Lucas or Luca? I just realized I might be calling you the wrong thing. Lucas Arts, yeah. But yeah, it's when A equals 1 and L equals 1, surface area equals 6. And so I was just giving the wrong piece of information for the answer, but yeah, you're right. Like, we do want this piece of information. No worries. Answer 12. Oh, okay. Yeah, the setup of it is tricky. Hey, Joseph, a show and tell? You think about it? What if the box is open? Does that change them? Well, now that's really, I mean, we can use a graphing calculator. I've done it before. I don't know what the answer is. It definitely changes the answer. Hey, Phobos. How's it going? What should we do for show and tell? Okay, I think I know. This solution is kind of dumb. This what it is, just basically drew the box, counted all the sides. Oh, I probably won't do it. Okay. Actually, wait. There's one more piece of the show and tell. Okay. Um. So I'm a fan of Kendrick Lamar, and this is I knew this because Joseph redeemed the show and tell for anyone who didn't see it. Ooh. I'm a fan of Kendrick Lamar, and I think last year in May, maybe even 2 years ago, he dropped a new album, Mr. Morale and the Big Steppers, and I got the fancy pants like box. Oh, I mean the box is empty because I took everything out, but it came with a vinyl of the album, which I haven't taken out of the plastic because I just like don't want it to age, but I feel like I really should and just like look at it. I don't actually have a record player, but I think vinyls are kind of cool. It's the only one that I actually own though. I should take it out of that plastic. It is a really nice box. It's like a premium box, as premium as cardboard can be. But it came with that vinyl, and it came with a really nice hoodie. Like it's like just well made. And the hoodie says, "It's it." It says Mr. Morale and the Big Steppers, and I don't know what just has some like related art on it. I think it's from one of the music videos. It is mint in package, but like I'm not like I feel like it should be enjoyed, not just like sat on and sold like years later. Hey, Dr. L. Uh, wait, King Kuma, wasn't it King Kunta the song? I don't remember though. You have faced death and we had a conversation. I said to death, I shall not fear you, for I have still the strength to fight you. That's like inspiring. I was expecting a. Then my wife into the conversation and said, "It's just the flu." And I made a bunch of. There we go. I was like, there has to be a joke in here, knowing Viv. Think it on you really cleared it up really clearly, better than my teacher. Oh dang. Okay, I'm happy to help you. I feel like it's Luca. The more I look at your name, but please feel free to correct me. But yeah, Kendrick is awesome. It's Lucas? Oh, okay. Well, I guess I'm glad I guessed right the first time, because I've been calling you Lucas the entire time. Okay, let me put this up away, but yeah, that's the show and tell for this one. Usin is a surname? Or I don't know how you pronounce it. Yeah, To Pimp a Butterfly is awesome. Hey, Joel. Love it. I'm also mad because right as it was getting cold enough for me to actually wear that hoodie again, we had a heat wave, and like today is the last day of it. It's only been like 2 weeks of this heat wave too. It's been ridiculously hot. It's impossible to pronounce for an English speaker. I can appreciate that. Good Kid, Mad City, yeah. The best Kendrick song? Hit me with it. Search it on Google Translate. See. Pronunciation. Where? Usen. Usen. I feel like that's too easy. There has to be... It can't be that easy. That's for English? Okay. Oh, that has a T on the end. What? That's not a word. That's just a sound. Please? I know it's a T on the end, and yours doesn't have a T on the end, but I assume it's close enough. Okay. It means someone from Prussia. Huh. Okay, I'm not seeing the exact thing anyway. Don't know story about a man who struggles to overcome his friends by his side to celebrate the club. It's called Bitch, I'm in the Club. Should I take a long bath or should I copy the hygiene of CS majors? I think you should take a long bath. You have to pronounce it correctly? Yeah. I mean, okay. Use some Dutch pronunciation. It's not showing me the exact thing, unfortunately. Bitch, I'm in the club. That's a podcast. Wait. It's a podcast, but it says Kendrick Lamar in the description? Oh, Google Translate. That's a good idea. Okay, let me just... What the heck is this bib? Oh, that sounds like Kendrick, yeah. Dutch. To use... Wait, one second, I want to get the pronunciation. Is it? Is it? Is it? Yeah, that's hard to pronounce. Close? I'll take close. It's the only time I watched Bros when I was drunk. Huh. That's weird this isn't, like, attributed to Kendrick, or it kind of is. I know that Kendrick also has King Kendrick as, like, an artist name. And there's some songs on Spotify posted with that name. Yeah, this is kind of generic. It's not bad, though. Fun fact, the two main Dutch pronunciations that they don't have in English are the Dutch EU and Dutch II. Oh, really? UI. Oh, and hey, Linux physics. I'm sorry. I saw your message, but I didn't say hi. Word versus ASMR noise. Yusin? I was like, well, the other ones sound like that. What's the French pronunciation? Be a drunk Korean pronouncing that thing. It's close enough. You listen to Kendrick a lot? Yeah, I do. Oh, I'm sorry, Joel. I saw that too, and I forgot to address it. Joel, you asked me about four long straight wires are parallel to each other, and their cross sections form a square. Each side of the square is 0.20 meters. I'm sorry about that, Joel. I should have told you that I saw your question. Determine the total magnetic field. I bet I can. Four long straight wires are parallel to each other. Well, I think we know the magnetic field due to they're parallel. Oh, this is a square wire. Oh, it's looping. Please don't. I don't need to hear it a second time. Oh man, they're square. You too, Lucas. Thank you for the question. Each side of the square is 0.20 meters. Huh. Woohoo, hey! How are you doing? Yeah, you can put a picture in Discord. I'm trying to it's not as simple as just magnetic field due to a wire, because that's for like cylinders, not squares. Good as always. How about you? I'm doing good. I started off the stream by drinking some coffee, which is rare that I drink it on stream rather than the tea that I used to always drink. But it's a good day so far. Nice. Magnetic field of a square wire. Interesting. Oh wait, no, that's not. Ugh. They're doing like loops, but these aren't loops. We have actual like wires like this. One. Oh no. Two. Three. Four. And they, oops. Ugh. Each have 8 amps flowing through them. I assume they're all going the same direction. Four long straight wires. What have you been up to, Hoo Hoo? Are you like working or studying or how's life been? Full work, life is boring. Ah, that sucks. Hopefully, you can save up, have some fun. Wait, aren't these going to be canceling each other? They should be going in opposite directions to add. Did I bake something yummy today? Kinda. I made some granola. And since Joel's potentially going to send a picture that I'm waiting for anyway, let me go and grab it quick. It's been leaving it to cool, but I'm gonna add in right now. There's oats, almonds, walnuts, coconut, and that's everything that's in there right now. And I'm gonna add in cranberries and chocolate, dark chocolate. So I really like having granola, just like a little like snack. I'm trying a new recipe though, and oh shoot, maybe you need the link, Jill. Should have thought about that. I tried a new recipe and it didn't like clump together though, which is kind of annoying, but it'll still taste good, I'm sure. Yeah, I made it before the stream. I'm just leaving it to cool while what am I trying to say? I made it to cool so I can put in the chocolate and the cranberries. Am I secretly a baker? I enjoy baking. I need to make some bread. I've been wanting to make bread for a couple of weeks and I just have not been getting around to it. You can try baguette. Yeah, I actually have like one of those like the pan to shape it into a baguette. Actually, it's right here. Let me... I'm sure I don't make them quite the same as you have in France, but I do always have like I can get the shape right because I have one of these pans. The flour we have is just like a little bit different, I think. I still make the So Baker thing. We made the best bread today in our Dutch oven. Ooh, I don't have a Dutch oven. It seems like there's a recipe of every kind for Dutch ovens. This is the recipe that I follow when I use that. So like this recipe at least calls it baguettes, but I don't know if baguettes have like a more strict like definition or anything like that. It's pretty easy though. Go away. Go away. Yeah. Are we missing some information here? Don't we need to know how far apart these things are? What type of bread was it, Dr. L? We don't know how far apart these things are? I wonder if it doesn't matter then, because magnetic fields drop off with 1 over r? So if you... Well, no. It was a no-knead bread without the dose it overnight, baked in the morning. Oh, nice. Just give him length of wires. That's weird, Joel. Do you know, like, Ampere's law? Like, I think... I'm not too good at magnetism. I'm only just learning about it, but, let me actually look at what it is. There we go. B.ds equals mu naught times current enclosed by path. So if we draw a square loop for Ampere's law, I know what the magnetic field of this thing should look like, actually. Oh, you know what? I think maybe if you look at it from like head on, like from that little square, my guess is the magnetic field should look something like that. I don't know which direction necessarily, so I'm just gonna like, you know, arbitrarily say it's like that, but they form a square. Wait, are these wires squished together? Like, does it actually... Is it supposed to be like this? Oh, it is supposed to be like this, it sounds like then. Okay. Um... So, we actually have something... Hey, Dwarf Keck. Hope you've been well. You're out? Alright, thanks for hanging out, Dr. L. Enjoy your bread. So these are actually all squished together into one big square? I mean, can we say that these are... Like, can we just use the formula for a normal wire? Because isn't this just the same thing as, well, like why can't we just add up all these currents and consider it as one big square? With 8 times 4 is 32 amps going through it. I don't get why. I guess for the center that might help. Can you do physics? Only barely. I know some electricity magnetism, but even then, my physics isn't very good. So I'm trying to do this physics problem right now, but I'm having a hard time with it. Maybe it's actually... Oh, man. No. I was just wondering if it's potentially... If this square wire is the same thing as, how a sheet of current has a magnetic field going like, or if we could consider it's like, I guess 4 different sheets of current that are like stacked into a wire. Maybe not. No, because this is a volume. Yeah, I'm sorry, Joel. I don't think I know how to do this. I think I'm not interpreting the question right. To be professor? That'd be cool, but that takes a lot of... I have a long way to go to actually become a professor. I think I'm gonna move on because I don't think I can do this one, unfortunately. This limit I'm still not sure about either. Oh, another show and tell? This one from Spectre? Oh god. Uh... Hmm. Oh yeah, it's because just like an hour ago, or maybe half an hour ago, Joseph redeemed one. But I can do another. Mohammed plays. Can I ask you about stats math? Yeah, I can generally do stats. Yeah, sorry, Joel. I don't know with this one. Dorkick, how do you get that number? Probability space. Oh, you might be doing some more advanced stats than I remember. I mean, I might know if you put the question. Oh gosh. Yeah, I can do like basic stats, Mohammed. You might be doing some more advanced stuff that I haven't learned. Okay, for Spectre Show and Tell, I don't think I've shown off my Rubik's Cube collection. So on my desk, I always have a Rubik's Cube. Oh, yeah, I'm not going to trust that Dwarf Keck. I have a normal Rubik's Cube and a 7x7 Rubik's Cube that just hang out with me and I fiddle with. Very demure. Oh no. Who with the young person memes? Everyone started saying demure. I don't know what it means. But I have more cubes than just those two. Ugh. Okay. I have a classics 3x3 piece of shit Rubik's Cube that turns like garbage. I have two other 3x3s that used to be good, but as they've aged, they've really become terrible and they feel terrible. But the more interesting ones are, I have a 2x2. This one is, it's pretty quick to solve. I forget the technique exactly. Yes, this is a swearing friendly zone. I have, it's called the Mega Mix, I think, or Mega Minx. It's a 12-sided, wait, 12, right? Yeah, 12-sided cube. It's basically the same as a 3x3, just a little bit extra steps. I have a 4x4. And then I have, it's a normal 3x3, but everything is the same color and the pieces are different sizes. So when you scramble it up, it looks super weird. It sounds like which Rubik's Cube you should solve in the redeem. That's true, I never said that you get to choose though. The Mega Minx, it kind of takes a minute. Do you have a collection too, Popos? Oh, that's awesome. What's your time for like solving a 3x3? Rubik's Cubes are for nerds? Yeah. You caught me, hoo-hoo, I'm a nerd. But yeah, I got these in high school because I was just bored in class and wanted something to do, and Rubik's Cubes wouldn't get taken away by my teachers. Is it decided by probability then? The probability is 100% for solving the normal 3x3 that I like and still moves quickly. You can solve one quick? Oh, okay. You better make two sides right in a 3x3 cube. Yeah, if you don't know the if you don't know the technique, then it's nearly impossible to solve just by figuring it out, I think. Yeah, I did have a computer science professor who, sorry, not professor, a computer science professor teacher in high school who said he wanted to try to figure out how to solve one without looking it up. I don't think as far as I know, he never did it, but maybe he did. Should have like a 0.1% chance that the cube gets randomly decided. The issue is I don't remember how to. I don't exactly remember. I can probably figure it out again. But like the 4x4 and the 2x2, I don't remember exactly the technique to solve them. And like the Mega Minx, no, yeah, the problem is I'm really rusty and I have to look up the algorithms. That's going to take a little bit, and that'd be like annoying. Yeah, it's pretty often like the 7x7 takes forever to solve and it's tedious, and I kind of wish that I would stop because it's just tedious, but it's really nice for occupying my hands. So I keep it on my desk and I probably solve it a couple times a day as I'm just like watching a stream or a video or something. I feel like there should be something better that I can do, but I haven't found anything better yet. Um, okay, so I guess we have a little bit of downtime. I don't think I'm gonna come to any realization on this weird limit problem. Well, I don't. There should be a substitution that's possible here. I just don't. T equals 1 over x isn't quite it though. I like those odds, dwarf keck. Yeah, I don't see what the idea is there. Not yet, at least. It's posted in my Discord though, so I'll be able to get back to the person if they if I have an idea. A 1x1 dice. um. Let me mark the problem as unread. I might try some mechanics right now, just to fill in the little bit of time that we seem to have here. It's behind his shoulder. He's like looking down. So I want to try to relearn mechanics. Because I want to learn relativity from Dr. Cook, and you need to be pretty decent with mechanics to do relativity, I think. So this book is a relatively short book on mechanics that I want to see how quickly can I get through this. A note to people who pirated the book. Oh. That's a nice little note. In view of the it's how to solve the Rubik's. I don't know what that means. What are you asking, Dwarf Keck? Solving problems symbolically. Looks like I'm gonna make a mistake. It's quicker. The problem once and for all. It's the general dependence of your answer on the various given quantities. Checking these in special cases. I was just showing the cover. You were commenting on the guy's head. Is that the table of contents? Problem and Solutions in Introductory Mechanics by David Moore. It usually gets messy, checking use such dimensions. Okay, let me actually, I was about to skip past this. Let's actually skim it. Oh, okay, sure. Same here, but I want to get better. This is bad at you. Hey, syntax. Eek, a pendulum. Hey, Fizzbuzz. We don't have to do anything with the pendulum yet. I'm trying to speedrun relearning mechanics, and so this is a relatively short problem-solving focused book that I want to see how quickly I can get through it, and hopefully then Dr. Cook can teach me relativity. Is why I'm doing this. And well, I mean, Dr. Cook's been talking about like doing a relativity class in general on Twitch, so I want to be up to speed for it. Some quantum physics earlier today. Boring. Not just casually doing some quantum physics syntax. I see you. Okay, so they're basically like intuiting what the period of this pendulum should look like, more or less. No, but it's barely quantum because like, yeah, then values sure be discrete, but not much more than that. Oh, okay. I mean, I don't know what type of calculations you do in quantum mechanics, so, or quantum physics. I think there's a lot of probability involved. Limiting such special cases. Yeah, Dr. Cook's been talking about doing a potential like course on relativity using book. Using this book. So it's not necessarily like a for sure thing, but I wanted to relearn mechanics a little bit anyway. And this, and Dr. Cook potentially teaching that class makes me want to like get up to speed quickly. Yeah. Whenever the probabilities are involved, there's one exercise related to it. It's like a simulation thing. Oh, okay. What class are you doing quantum mechanics in? Yep, Taylor series for limiting cases. Sure, sure. Velocity. Oh, okay. Oh, and if it's a class, okay. I didn't know what you're doing. I mean that I never did quantum physics in my physics class. I never done quantum physics in my life. Wish you hadn't. But you can go around and tell people that you do quantum physics and like they'll be impressed. Okay, what's the strategies? It's as long there's no need to memorize it. Read the problem slowly and carefully. Yep. And with things you know and things you're trying to find. Yep. Draw a picture. Free body diagrams. Calm down to its basics. Wisely. Yep. 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 Numbers to letters. Yeah, sure, sure. Well, this is an interesting one. Well, I would try to do this. I made a graph in math class today that looked kind of like the feet of an Among Us guy. I think you know your mission then, Syntax. You need to make a Desmos like art thing of an Among Us bean. Well, but you need to make one though. You know, I'm sure you can make a better. You have it saved. Oh wow, okay. Be organized? No thanks. I'm surprised that so much of like there's so many pages devoted to these strategies that I mean maybe just because I'm maybe I just had like decent teachers who like implied this, but I feel like a lot of these are things that I've kind of like have seen before. Scrolling through my decimal history is always a fun trip down memory lane. Imagine your teacher explaining the situation. I feel like that's like asking ChatGPT. Like me trying to imagine my teacher would say, I may as well ask ChatGPT for an answer. In terms of how much I can trust it. Just do something. Didn't you tell me not to wander around randomly? No, you're contradicting now. Come on, Morin. I don't know. Almost I didn't go for a walk. That's a good piece of advice. It's always like, or not always, but it's usually when I put a problem away and stop thinking about it for a bit that it suddenly hits me. Oh, there's actually questions on this first one. We haven't even talked about any like physics yet. What the heck? There's a lot of these. Oh, these are the answers right here. Okay. Oh. What's problem solutions? I guess let's look at a few of these. I feel like this is pretty skippable though. Fully commit to an answer before checking to see if it's correct. Well, that can still be gamed, but oh well. Task given problems by a certain length, which defined quantities could be the answer. LVA, T, and M in this and the following two questions are given. Not AT. Not MVT. Not that. Not that. V squared over A, probably. Yeah, because the second squareds cancel. And you end up with just meters. So I'm going to say E for number one. Dude, I feel like I know this. 1 mile per hour equals how many meters per second? Okay, yeah, that's good to know to do. I feel like I know that. Don't solve these graphs, just use dimensional analysis. Data must be the largest angle of inclination for which the block doesn't slide down, which the following is true. Ooh. But that's kind of interesting. Let's think about it. So it's on your cube root, PAL mockup in Desmos. Good lord, is it scary looking? So the gravity on Earth is stronger than the gravity on the moon. So it's pulling down on the block stronger. And so you presumably need to, well, I feel like I know what it should be. I think there's like, it's not quite that clean because if we have a block like that, like what I want to say is that more gravity means that the friction is stronger. But more gravity also means it's being pulled down harder. So that's the, I feel like there's like two competing things and which one is stronger. I assume they only want us to think about how stronger friction means you need a bigger angle. No. You're saying it's A? So it is being, the increased gravity is partially offset by the block holding it up. Right? Whereas the friction just increases without being offset. Is that, and so what will that mean? If there's more gravity, why don't say if there's more gravity, you need to angle it higher. This is not trivial though, to me. I think intuitively it should be more gravity means higher angle. Or have it reversed. Like, so you're saying A, which is theta max is larger on the moon. So you're saying the reverse of what I'm saying, which is higher gravity, lower angle, which could very well be it. It's... Or is it the same? I don't actually... Yeah, we do have the solutions. I just want to think it through. So like I'll check the solution, but I want to. I feel like I can figure this out. I can see justification for all three of these answers right now. Is my issue. They say they use dimensional analysis. I don't see how you use dimensional analysis here, though. Dude, I don't know. You're saying C spectry? Normal force is going up. Gravity is partly going down, partly to the right. Friction is going to the left. A, B, and C locked in. And so if we raise gravity, I think it's the same. No? Yes. If we raise if we raise gravity, I think we're increasing the friction. Like these two are increasing. I think friction is proportional to normal force. It's really like mu times the normal force. I think we're increasing the friction at the same rate as, like, we're increasing the force to the left at the same rate as we're increasing the force to the right. So I think it's the same. Yeah, we're looking at the answer. 1.5. C. Yeah. When say the maximum velocity dependent on the mass m of the block, relevant acceleration due to gravity g, and the coefficient of friction mu. Oh, that's their justification. I see. I was wondering how you use dimensional analysis here. Interesting. Anders, hey. All right, that was a cool question. I did it in the wrong way. I used my physics, a little bit of physics knowledge I do still have, but too easy. You're right, Spetri. To really ramp it up, we'll just go right into oscillations or something, you know. All right, see you, syntax. What's 1.6? Defeated, I must sleep. The mass m oscillates back and forth on a spring with constant k, units kg per second squared. If the amplitude, the maximum displacement is a, which defined quantities is the maximum speed the mass achieved as it passes through the equilibrium points. Let's get this into paint. So we're only doing dimensional analysis here. No real physics yet. So we expect maximum speed. Expected units meters per second for speed. The first answer, kg per second squared. So this one, the masses cancel. A is length, which we'll call meters per second squared. So A is out, so the seconds are squared. This is the exact same thing, but it's A squared, so it's M squared. S squared, that's out. But I mean, we just look over here and see it should be D, because it's the square root of the thing that we got. This one is root M over S, which is certainly not right. And this other one is kg squared. Well, not squared, because it's square rooted. And second squared? That's nothing. So I'm saying D. D. Okay, let's go to a different section. Don't solve things from scratch, just check special case. I have to use the bathroom. I'm gonna be back in like 1 minute. Okay. We're here. Um, gonna 12. Oh, don't solve it from scratch, just check special cases. Hmm. Oh, well, okay. Well, the first thing is that this is parallel to CD. And so that angle C should be the same angle because they're alternate, whatever. Whatever that word is. Um, Now, can we think about A or B? I doubt D is the same. Just check special cases, they say. What special cases? At 45 degrees? That seems like a special case because we know that's also 45, which means that is also 45. Can we still say anything about this upper triangle? I think we can. Can we, though? It's like, I don't, like, I'm thinking about, like, if you have a line that you know has a known slope, if it's 45-degree angle, like -1, and we have a perpendicular line, that's basically what that AB vector is there. But just because we slam a triangle on this thing doesn't necessarily mean anything. It does. It means the same angle. So I think one of A or B do have to always be equal to theta because of that. Like slope argument. Because they're always perpendicular. Which one though? If we... I'm trying to visualize what happens to this thing as theta varies, but this isn't like they're saying the checks, but like what other special case is there with the right triangle? Like a 30, 60, 90? I guess that's the 60 visually. So, okay, actually, you know what? I think what's a better exercise is just compare a big angle to a small angle and see which ones match. So like big angle means perpendicular is like that. So short side there, long side there. So if any of these angles do match, it's that one on the bottom, right? Whereas if we have a very small angle, if any of these angles match, it's still that one. So maybe that's what they want us to do, and we can conclude from that that it's A. C. I'm saying A and C for problem 12. A and C. Yep. Never draw anything close to a 45, 45, 90. Yeah. That wasn't a very helpful case to look at, as it turns out. Except for that geometry, like little parallel transversal thing, but let's try 13. Just check special cases. Ooh, I think I... Oh. What? No, 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 no. Always be sure what your window you clicked into before you do Control A and then delete. That was almost bad. Applying tension T in each string. I feel like, well, I think there should be a dependence on theta, because if we have strings like that, I think this string is doing a lot more work. So that's a... That throws out A. If theta equals 0, we have it all just in one string, so we'd want this to be mg over 2. So it's potentially that one or that one. What if theta equals 90? I know that's... That should maybe not be allowed, which would lead me towards E. Because that seems to violate the spirit of the question to have this situation. Maybe it doesn't. Maybe it's still just mg over 2. Why should the tension be equal in these strings? It seems like this question is implying that, but with the first thing I said, it seems like with this first sample, it seems like the tension shouldn't be equal. So does having it at an angle help or hurt? I guess it hurts because the strings are pulling against each other rather than working together the bigger that angle is. So the smaller the angle is less tension because they're not pulling against each other as much. Is that right? Which would mean it's going to be sine theta. Yeah, I guess like this situation is the least tension, this situation is the most tension. So theta equals 0 should be least. And theta equals pi over 2 should be most. But you make it look like sine theta like that. What I don't like about it is that if theta does equal 0, then you get 0 tension, and that shouldn't be true. So... But then dividing the sign instead doesn't do what you want. So maybe it's E, because if you divide by, if theta equals 0, that's just 1, you get mg over 2. That's the answer I expect for theta equals 0. If theta equals pi over 2, you're dividing by 0, so the tension is getting infinitely big, which isn't quite right. But you are increasing the tension. So I think E is my answer. This is number 13. E. Okay. Nice. Furlongs per fortnight squared? Meh. Is this just unit conversions, or is there anything else? Oh yeah, Anders, I'm just doing some random studying, so there's no queue right now if you want to ask your question. Hey, Debbie Young. My channel isn't big enough for memberships on YouTube. On Twitch, I have that stuff unlocked, like subbing that stuff, but I also have stream elements. I think it's that command. Maybe it's tip. So yeah, I mean, if you want, I do have that. But it's never like necessary. A Hasse diagram? I haven't heard of it. That link seems a little bit weird. Oh no, I don't know, it's fine. It's just the line break that made it look weird. I've never worked with an ordered set before either, or a partially ordered set. So I don't know the definition of that, but I'll try. But I don't actually know what it means to be partially ordered set either, to be fair. I've heard the term a lot, but I've never... Oh, that's what a poset is. A less than or equal to A. Okay. I think I understand the definition then. And so partially ordered is called that because it may have things that are incomparable, but that's okay. That's why it's partial. Okay. And so how does a Hasse diagram represent that? I maybe I don't want Wikipedia's explanation. For the Wikipedia, for the inclusion of sets. Yeah, I don't quite know what to make of that image, which is why I was looking for a different one. Oh, so okay, that's a nice. That shows the hierarchy. Like literally, things that are lower down are less than the things above them. P is related to Q. Okay. For 3, 4, 12, 24, 48, 72 in divisibility. So 4 divides 12, 3 divides 12, so they're both less than that. 3 and 4 all divide 72 and 48 and 24. 12 divides 24. 12 does also divide 72. That's okay, transitively connected. Okay. Or yeah. Three and four are not related to each other and they're smaller than the other elements in the set. Okay, and yeah, 48 doesn't divide 72 likewise. So that question, oh, for yours? No, I deleted that. The VOD is should be up though. Okay, so I feel like I understand what a Hasse diagram is then. I'm not gonna be able to answer a question about it, but I'll try if you have one. No, sorry for Anders, not you. Turn infinite. Hmm. That does seem to pose a problem for drawing a diagram. Oh, I see. No, that's completely fine. Uh, we know I assume that's for a partially ordered set that's finite. There exists a diagram of Hasse. In some particular cases, also you can, I assume, draw a diagram of Hasse for infinite sets. There is an E equals 0, 1, 1/2, 1/3, 1/n. Whoa. So every integer and every reciprocal of integers is this set. And 0 is just 0, not the reciprocal of 0. For E definitions, is -1 in E. I don't see why not. They do leave out -1 from the examples here, but I don't see anything that would exclude -1. I think so, yeah. Was that your only question, or was there like something more about it too? Definition of needs define the order. Oh, okay. Yeah, to me it looks like -1 is included in this, and that your definition looks good. Because yeah, they do say that 1 is possible value for n, and they do specifically say that -n is included in this, so maybe that's some justification too. It's definitely a little bit weird though. Compared by the 1/n rule. Yeah, it does. It's I guess it's weird because you definitely can't show the 1 twice, but because it's a set, but it feels like it'd be inconsistent if you can't include. They don't show a negative fraction either, do they? I kind of wish they. Oh. Wait. They don't show a negative fraction. I wish they did. Maybe -1 isn't in the set. Only positive n. Oh, I think -1 isn't in here. Or is it? I don't know. That's really hard to tell. Worst case, we'll miss 1 point. Yeah. Um, can we figure out the diagram? Yeah, that's really vague. I can see justifications for both ways. I feel like -1 should be in this morally, unless it breaks something in 1, 2, or 3. But I feel like it should be in there. Can we figure out the diagram? Well, what are the rules that we have? 0 is less than or equal to x for all x belongs to E. Everything, okay, so 0 is the least element. Okay. 2, 1 over p is less than 1 over q if p is greater than q. Okay. 3, 1 over n. I don't know Kubre. I don't know what this means either. What is y? Oh, e, not y. It's not like a variable y, it's and. 1 over n something, n plus 1 and negative n plus 1. Covers. There's no elements in between. Okay. So we're not given any way, like, A covers B if A less than B, and there is no x such that A is less than x is less than B. For B covers A, okay, that makes sense. Huh. Just copy that down. So that means 1 over n covers. So n plus 1 is less than 1 over n, and like it's saying that that third thing is saying this. That's a weird ordering. Okay. And we're never given ordering for the integers, right? Like, well, I guess this is the ordering. Okay. So then the example is 1/2 covers 3 in -3. um 1 covers 2 in -2. So okay. It seems like the fractions reign supreme in this ordering? And so if we go at it from top to bottom, is it this? But the 0 is going to be weird, where 0 gets all of these and all of the and all of, wait. I'm sorry. I did that wrong. I should flip all these. Another dumb E&M question. It's not dumb, but please do ask it. Only I get to ask the dumb questions around here. Yours is fine. This is... That's how I'm reading a Hasse diagram for this. This feels weird. Oh wait. No, never mind. Don't have to worry about 0. Hey, $10. The last arrows I draw shouldn't be there? Oh, because of transitivity? Yeah, okay. I agree. Right. You know what? -1 never really comes up. We're not considering rule 2. Ah, fuck. You're right, we're not. If P is more than Q... Ugh, okay. The more I look at it, the more I think -1 might not be in this. And I feel like it should be. So maybe it's actually like... Well... Yeah? And the ... is also... This 1/2, I don't know whether to put on the same level as the 2 -2, I guess. Let me look at what Henrik is asking. If charged particles create electric fields and moving charged particles create magnetic fields, how come a permanent magnet and a magnetic field that can appear strong? I wondered that exact same thing, Henrik, and I don't know the answer. So I know that oh, where is it? Sorry, Andrew, I'm just looking at a I think I can address Henrik's thing quickly and then I'll come back to it. Where did they do this diagram? Here we go. So if you just have a random neutrally charged material, the protons are fixing, electrons could potentially be wandering around in random directions. And, you know, on average, they're not moving if you add up all the velocities. But on the right is the same image, but there's a slight drift towards the right in all their velocities. So you took this entire diagram, shifted all the velocities slightly right, and that induces a current, and I think it has something to do with that, where just everything having a slight drift is enough to make, like, as a whole, a current. I think that's what's happening. But the term for it is permanent magnet. So maybe there's something more that's happening. So that's just like my own theory for why it happens. I could all be bullshit. Just as a warning. Go away. Go away. Just tell me the answer. Oh, so the electrons are spinning. They in chapter 6 they ask about a spinning sphere. That must be why they ask about it, because these are basically spinning spheres. That's a question that I think I chose it about calculating the magnetic field due to a spinning sphere. Huh. Okay, so I guess throw out what I said, and it's actually electrons spinning is the movement. Hey, Rintu K. Kuruthu. And Territar, are you going over Maxwell's equations? Not yet. We will eventually. Or there's a question from Super Henrik in the Twitch chat about how do permanent magnets, like, how do they create a magnetic field if there doesn't seem to be a current that's moving? Yeah, yeah, if I'm not right, we brushed on at least 2, possibly 3 of Maxwell's equations, though, as we've studied E&M. Yeah, Gauss' line on Paris law. Huh. So it's I think it's something, Henrik, about you have to manufacture it in the presence of a magnetic field that's external, and that aligns all of the spins inside the material, and it only works with certain materials like iron. You have to give it a preferred direction, I guess, otherwise it's going to be random and things will cancel, is how it seems. This website is explaining it. Yeah, we haven't quite gotten to this yet in the E&M book, so I'm not this seems like it makes sense where you kind of impose a preferred direction onto the material to align everything. But I don't have a good explanation for you that I want to just Google and read out loud. Okay, I'll go back to Andrews's question. Thank you for that though, but I think probably need another couple of chapters before they explain that. So yeah, can we compare? Like, I guess my question is, can we compare 1/2 with 2 and -2? I think if we can resolve that question, we know what this Hasse diagram should look like. Right now I'm saying they're incomparable. We know that you think that's the correct one? Yeah, I don't see how we can. Well, is it like this, or is it like this? Or sorry, oh my god, I keep flipping it. Two minus 2, 1/2. And then, like, that's what I'm trying to figure out, I guess. Oh, true, after it. Mom says it's all my fault. Hey, we'll welcome in. How does Magnetism think about the structures of music? I personally would love to know more about music, but I don't know anything about it. So right now the answer is I don't. If you consider me a mathematician in the first place, I guess, which I don't know what the definition of that even is, but I'd love to know more about the connection, but I haven't actually quite studied it at all. So someone else in chat may have a better answer for you though. You think that these are the same? Really? Doesn't this diagram imply that? Well, I guess not. I was just maybe drawing it weird. Yeah, you're right. It's the same. I'm just drawing it weird. Hey, Bob. Okay, so the problem was it's in Spanish. Yeah, I do like that organization better. The problem was we have it. You have to create a Hasse diagram for this infinite set with these comparison rules. So you don't need to know what all this says. You just need to know that. Let me even zoom in. This is the set that we're working with. Partially ordered set. And then these are the rules that we use to compare. And we have to draw, yeah. It's with 2 S's. Like that. So the first question was, does the set include -1? First I thought it was going to be yes, but now I think the answer is no. Number 1 says that basically 0 is the minimum element. Number 2 is just how you compared fractions normally for which one is greater than the other one. And then number 3 is the weird one where 1/n is greater than n+1, and it's 1/n is also greater than -n+1. But from those rules, you can construct a diagram that represents that hierarchy. And I think we've done it. Yeah, I was I guess like simplifying a bit, but covers is a special. It's a stronger thing that I kind of like played around with down here. The answer is 7. Thank you, Malcolm. I think conjuntos is set or sets for conjuntos. How's it going, Malcolm? Yeah. I'm doing good too. Um, just been learning something new about partially ordered sets, which I've never actually even looked at before, but they don't seem too bad. Oh, and the Zero people got back to me about the ticket. They said they would report it. It doesn't sound like they had heard of it before, so but they said they like talked to the mod creator about it. Oh, yeah, right. You have that emo bomb. Nice. Well, thank you for whatever bit it took to blow that up. For whatever reason, my stream activity feed doesn't show those bits, but yeah. Um. Yeah, exactly. That's kind of crappy. To lose out on our mostly the filters there. Yeah, I feel pretty confident with this diagram. It could be. I wish I organized it like this, but um, I feel confident that like this format is right. There, something like that. Oh, I just don't know how to count. I don't know how to use negatives either. There we go. No worries, Malcolm. Appreciate you saying hi. All right. It's kind of an interesting question. Okay. Yeah, let's see if the book explains that. Magnetic fields and matter. Ferromagnetism seems like it would be it. Okay, I'm happy to try it if you want, but if you think you got it, then feel free to drop them in there. There has to be a meme, like, making some pun about ferrets and magnets, right? Like, something that's ferromagnetic is just like a ferret made of metal. There has to be something there, right? I think we probably need to oh yeah, no, I'm pretty sure Pharaoh has something to do with the Latin word for iron. I just only now noticed that the word ferret is hidden inside of this. And that kind of made me laugh. Oh, there's a Pierre Curie. But I feel like that's like that's like an idea for a Pokemon right there. A magnetic ferret. I don't know. I'm just kind of saying stuff. Okay, I don't think I can just jump into like the end of chapter 11 here and understand what's happening. Oh well. But question. I think I chose it as one of the ones I was intended for the reading group, but there's only one about getting the magnetic field due to a spinning sphere. Oh, never mind. Oh, that's the vector potential for a spinning sphere. I would not have chosen a 4-star problem. Field at the center of a sphere. It's spinning with angular frequency omega. Yeah, that's kind of cool. That it's going to hint at a future. I assume the book is going to talk about that in a future chapter. Okay, but since we have some more downtime, I have just started on relearning mechanics, trying to speedrun it. Yeah, I didn't see them before either. It's just a graphic representation of a pushed over set, I guess. Sorry, you probably already knew that because you saw what we were just doing. Mechanics, I hear whether Lagrange equations. Oh god, I don't know what those are. I don't know if this book will go over it. I'll show what the cover is. But I wanted to try to quickly relearn mechanics, and so this book is it's apparently pretty like problem solving focused book. So I kind of just want to relearn the stuff that I have forgotten. Where would the Lagrange equations potentially be? It's just an introduction, and then it goes right into the questions. Wow. Some more question about calculus? Oh, I'll definitely take a look. Oh, it's purple. I've looked at these before, apparently. Huh. Oh, yeah, I'm probably not doing this. I'll definitely look at a calculus question. Limit by definition, sine of x. Oh no, epsilon delta. Oh gosh. Oh, not epsilon delta? I would be so relieved. Derivative at okay, good. That I can do. Because that does involve sin of x over x, right? Hopefully we can just say we know that to be 1 rather than having to go through the proof. I feel like there's a simpler way that we did in Zach's class. I can't remember what it was though. So the question is find the derivative of sine of x at x equals pi over 3 by the limit definition of a derivative. One where x goes to x0. Right. Well, actually, wait. Tell me which one to x. Okay, yeah. So that should be the limit as x goes to pi over 3. Of sine of pi over x plus pi over 3, I guess. No? Yeah, x plus pi over 3 minus sine of pi over 3? No? You're right. Okay, yeah, I'm getting it mixed up with the other version of limit. Thank you. When I was first taught this, I was only ever taught the one with h going to 0. And so I using the other one with x approaching a, I know it, but I like never think about it. Sine of pi over 3 over x minus pi over 3. Okay, thank you. So useful in learning these. Exactly, Territar. I never knew that for the longest time. It would have helped me too. So I guess we can evaluate sine of pi over 3 to be root 3 over 2. It may or may not be a helpful step, but actually, you know, it's kind of annoying. We have to use this version of the limit. The other one I think is easier. Of course, we can't just, you know, we'll make this one work, but when I proved this derivative before, it was with the other one. How can we do it with this version? Oh, Fembox, that could be it. You know, let's just keep it as sine of pi over 3. Interesting idea. And so you're saying to group these two. You can see how that looks, because I don't really have an opinion on what grouping is better right now. So using the sum identity, and you hopefully wrote the identity for us in chat. Sine of the first thing times cosine of the second thing plus cosine of the first thing sine of the second thing. Okay. So where does that get us? Um, well, okay. We can split them to two different limits now. Because this limit is fancy sine of x over x. Territar, I'm assuming that we can say sine of x over x is 1 without having to prove it. But I guess Andrews, correct me if I'm wrong. Like, yeah, because this I will need to fact that, like, that thing in the next step. We can assume it? Okay, good. Oh, on this left one, ooh, yeah. We have the same thing with cosine, right? Sine pi over 3. Do we have the similar limit with cosine? Minus 1 over x minus pi over 3. Okay, so this piece. Hey, me Machine Rex. How's it going? It's going to evaluate to 1. We could do a change of variables to really show it, but the cosine pi over 3 is just a constant coefficient. So, I mean, let's just write it on the outside to really do it right. I did order a tablet, by the way, for writing properly. And if Amazon is to be believed, it should be here on Saturday. But I also don't trust Amazon to actually say their delivery dates accurately, but because they've been sitting on another one of my orders for like weeks. But I think it'd be kind of nice to actually have a tablet, because this writing with the mouse gets old after a while. I am. Oh, you know, Rex, do you stream? I saw that Penn Center posted something in his Discord that made it seem like you stream. Or maybe you used to stream, because I looked at your channel and then as it didn't seem like you had streamed in a while. But I'm curious. Nobel Prize in Physics awarded recently for work that who was that for, Finbox? This limit over here is like the analog for the sine of x over x with cosine. I think it's also 1. Maybe let's Google that though. Oh, you can just transform it into the sine of x. Okay. Oh, wait. No, it's 0. Oh. Got an iPad. You want to get an Apple Pencil and start practicing on that. I've been taking really nice notes on my iPads. Ooh, interesting. That's got a cheapo, like, tablet without a screen. It seems like it's going to be really weird to get used to, but they seem to be popular and people can figure out how to get used to them. Let me just quickly do this cosine limit off to the side. So I don't remember if it's um 0 or 1. It's multiplied by cosine x plus 1 over cosine x plus 1. The top becomes sine squared. Chad MS Paint supplants the whiteboard at long last. True. MS Paint is a choice of gentlemen. Minus sign? Oh, yeah, thank you. Hey, Matthew. Hope you're doing well. Do you just make that the product of two limits? And sorry, Anders, if you already like know this one offhand. I just can't really remember if it's 0 or 1, so I was just thinking work it out. If it's a negative, I don't know. So that this piece is 1 or negative 1. This piece is 0 over 2. So the limit is 0. I guess I probably could have just guessed that and then verified because I know what the derivative should be. Okay, so what we're saying is that that thing is 1. Oh, yeah, we should end up with cosine of pi over 3. What am I saying? Why do they exist? Right, Renga. I don't think we have to go that far in proving that, but yeah, you're right. So hey, Renga. Okay, so we do get cosine of pi over 3. We could evaluate that if we wanted, I guess. I think that's how you prove it. And Venlox's idea was the right one to do minus pi over 3 plus pi over 3. It's better than epsilon delta. Yeah, I way prefer for this one doing the other limit definition. But this one's possible too. Yield add pi over 3, subtract pi over 3. Exactly, yeah. Yeah, like That one, to me, is way easier because you don't have to spot this weird going from here to plus pi over 3 minus pi over 3. It's you start out with the sign of x plus h there, and that seems like something you can use an identity on, but we had to use this one, so. Hey, Edison Nogales Antezana. I recognize that name. Well, welcome back in. What is the solution of an exact differential equation of the form f of xy equals c? I'm a little confused on that. I just started learning. Let's see if I can remember that. Yeah, 0 is the cause of and solution to all of math's problems. In one. Yeah, it's a Simpsons quote. I haven't watched that much of The Simpsons. I do really like what I've seen, but I didn't have the channel as a kid. So, I've seen very few episodes. So it's like, whenever I was at a friend's house or something. And it was never on like any of the streaming services. As I think it's on something now, but oh, interesting. So I'll link you to this webpage if you want to look at it for yourself. But like this entire section is where they explain the answer to your question there. You don't stream internet's poo-poo? Oh, okay. Some Fox 5 to 6 every weeknight when I was a kid. Yeah, I never had Fox. I don't think I did. I mean, I never flipped on the channel, I guess. Okay, so the idea, I think, Edison, is that if you have a differential equation of this form, and it's also sometimes written equivalently like this, but the explanation works the same in either case as far as I know. So I'm going to work with what the website gives it as this case, but this thing down here does exist. This differential equation would actually be much easier to solve if we can magically find a function that we call psi. I think it's psi. I integrate some text with this. Function psi of xy such, oh god, terrible C, such that psi sub x, or I guess not such that, but that satisfies psi sub x equals m and psi sub y equals n. And that's because if you know multivariable calculus, which if you don't, it's going to be weird. If you take the ordinary derivative of psi with respect to x, Um, actually, let me draw a tree diagram. Psi is a function of x and a function of y, but y is also a function of x. So if we take the derivative of it with respect to x, we get the partial with respect to x from this branch. And from this one, we get the partial with respect to y times the derivative of y with respect to x. And oh, look at that. That's the exact differential equation that we have up here. But by writing it in this form on the left side, I'm sorry, we know it's also equal to 0 because of the setup. And the trick here is we look at the left side and we equal it to the right side. Obi, hey, this is right up your alley. Actually, I remember seeing you explain this, I think. So if we, from the above, we know that this statement is true, that the derivative of psi with respect to x is 0. So here we could simply integrate each side with respect to x. And so something similar to Dr. Gold just now. Oh, funny. And so this becomes just psi on the left, and on the right, 0 integrates to 0 plus some constant of integration. So that's where that comes from. Oh, and sorry, you said f of xy. I've been using psi because that's how I was taught. But my psi is your f. Exact equations, yeah. I hope that makes sense. Let me know if I lost you there, though, Edison. Hi, I'm from India, and I don't know where to practice from for the digital SAT. Can you recommend some free question banks I can practice from? In Khan Academy doesn't give you question bank. Ooh, SAT. There should be resources out there on Google if you look. I didn't study for the SAT myself, to be honest, or I hardly did. At least when I was taking it, though, we would have just studied out of a book. Now, there weren't websites out there, but couldn't find anything, really? There should definitely be some YouTube channels at least, but like, okay, there were like, they called them PSATs for practice at SAT. And I see your drawing thing, Anders. Oh no. Hasse Diagram, the set of positivizer of 30 ordered by divisibility. That actually, I think it's a small one. "93 practice questions." I think Zach will be on in an hour and a half or so. So this seems like a potential website for you. No worries, Edison. So I guess there's that for you, Dr. Drunkenstein. I don't have a lot of resources offhand, though. And Joel and Umana, your channel's so underrated. Hope you grow and reach a large audience. Oh, well, thank you for the kind words, Joel. So yeah, it seems like there's more potential things out there too. But I haven't had to study for the SAT in 9 years or something, so I'm not sure anymore. So the Hasse diagram is a set of positive divisors of 30 ordered by divisibility. Funny way to ask a question. Ordered by divisibility. you would be after this one critical. But yeah. Okay, well, the divisors of 30. 1, 2, 3, 5, 6, 10, 15, 30. And if it's divisibility... Oh! I can refund you, Anders. I'm not using the whiteboard for the foreseeable future, though. It's either a paint drawing right now or no drawing. Because the whiteboard's just too much of a pain to set up every stream. Yeah, I'm sorry. I'll refund you. Like, I had so many things to do, like, physically that I have to, like, start setting up, like, 15 minutes before each stream, and it just got kind of annoying. Directional derivative from critical. Too deep. Okay, find the directional derivative function of the given point in the direction of the vector v. How do these work again? At that point in that direction. Miro is pretty cool. Oh, like a drawing program? Yeah, likewise. Go look at this AT, Trunkenstein. Oh, okay. Yeah, I don't know what program I'm going to use with the tablet, so that's good to know. I saw people were talking about like Journal++, but the J is an X. What'd be really cool is I want to see if like any of them will let you use scripts, and if I can figure out some way to like get Twitch integration inside of that program. I think that'd be kind of neat. That sure looks like a dot product, yeah. Edison. Oh, and yeah, it's the only way that I was... Actually, I don't remember how I was taught it. This is like the result of a dot product, though. Okay. So I guess what we need is the partial with respect to each of the variables. We plug in the point into those partials, and then we dot it with the vector that we're given. It's the dot product of the gradient with the unit direction vector. Oh, it is a unit vector. That's a potential trick they can pull. They don't give us a unit vector. Oh my god. Sneaky. Okay. Well, let's start. So, hey SPQ. How's it going? The directional derivative of h is equal to h, the partial of h with respect to r at 1, 1, 1. We have to figure out... Let's get v as a unit vector. I do think it has to be a unit vector, yeah. Oh, so it's going to mess up the magnitude. Yeah, what Tertar is saying. So I'm going to take v, I guess before I even do this, let's just take v and make it a unit vector. Otherwise, it's going to throw off our answer if it's not. Oh, you can do that later. Yeah, I guess it makes sense, Funbox. I'd rather do it now before I forget. Actually, we'll name this to be U. And we'll just make that du. Oh, if you want me to skip right to that part, I definitely can. Do you want to see the entire thing or just that, like, that bit of it? You know how to do the rest? Okay. Well, if all you need is that h sub r of xy, oh, xyz, rst. Yeah, I mean, these partial derivatives are tricky. Because you have all these extra pieces of information that you should ignore, but it's very hard to actually ignore them. Okay, so for the sake of the partial with respect to r, we treat r as our variable, and every other variable we pretend is a constant. So when we're doing the partial for r, we may as well have ln of like 3x plus 1 or something like that. Like we're going to be doing basically the same thing, except this one is actually 6s plus 9t. So when we take the derivative of an ln, first we do 1 over that thing, 3r plus 6x plus 9t. Now, chain rule, we have to take the derivative of the inside, but only caring about r. So this entire thing on the right is a constant, and it's going to become 0. The derivative of this 3r is just 3. And so that's the key idea here. And I notice there's a cancellation with all of these. So the partial with respect to r is 1 over r plus 2s plus 3t. And then same procedure for the other partials. They'll look very similar. So when we take the partial with respect to s, same thing. So we're looking at s as our variable, treating the others like constants. The first step, we're still going to do 1 over this thing, because that's just how ln works. Now for the chain rule, we take the derivative of the inside with respect to s. This goes to 0, the 9t goes to 0, the 6s becomes 6. And we can cancel a 3 out of these. So this is going to become 2 over the exact same thing. Zach, the Zachinator. Now at Wendy's. And so the final one, it'll be the exact same format here for respect to t. T is our variable, the others we're pretending are constants. So first step, we're taking the derivative ln of something. So we're going to do 1 over that something. Now for the chain rule, these first two derive to 0. The last one derives to 9. Going to do the similar cancellation. Okay, so does that make sense? Critical? They end up looking very similar, and that's just kind of how it goes for this one. They could end up looking very differently, but in this one they look the same. Derives, yeah. Tiring but going well. Nice, nice. No worries, critical. We take the dot part of the unit vector, you're essentially finding the component of that vector that goes in the direction of the unit vector, so it can also be thought of as magnitude of the vector times sine theta cosine theta. Hmm. Uh, yeah, if you want to ask about the unit circle, I'll answer that, but I'm going to wrap things up after that, I think. My arm is getting sore from all this painting. Hmm. Just bring up a unit circle because it'll probably be helpful. How come 3 pi over 4 needs to be minus 1 over square root 2 and pi over 4 stays square root over 2 over 2 when it comes to directional derivative problems? I assume you're doing cosine? Let me, I guess, get this into paint. So my homework is to solve the remaining 6 millennium problems. Please help. Hey, not in box. I'll get right on it. And that's just so I'm assuming you're taking cosine pi over 4 and cosine of 3 pi over 4. And if that is the case, I just kind of look at the x value for pi over 4 and see it's positive root 2 over 2. In the x value for 3 pi over 4, which is minus root 2 over 2. They're just on different spots in the unit circle. Where are inches and pounds on the unit circle? I don't see all the units listed. Oh no. They all cancel it out. That's actually true. Yeah, Obi, you're right. You had to memorize all those values to be on 7.5, 15, 22 degrees and 30 arc seconds, if I'm reading that right? No, 30 degrees and 20. I don't know. Yeah, that's terrible. I can't believe you have to do that. I don't get what you're asking, critical. Like, where are these cosines coming from? No, it's okay. I just am trying to figure out what could cause something like that, but I'm not even sure what's happening in the first place. Uh, okay. Yeah, I'm just not sure how to interpret that, I guess. No worries. Oh yeah, Debian. I think I'm gonna wrap things up here for the day. Um, if anyone feels like it, there was actually, let me call it out. I'm still gonna think about it for myself, but there's this kind of interesting limit problem. Number 2 here. So it's in French, but the question is to deduce the value of the limits here using the identities in number 1. But the trick is no L'Hopital's allowed. You can refresh it. So I'm gonna keep on thinking about this too. It's posted in my Discord, so if someone else comes up with an idea before me, like feel free to post it. It's right here in the homework help. It's the one that says "Yo" by Bro. So yeah, I mean, Zach, if you have time, please do. I was able to figure out a way to do it with L'Hopital's, but the person isn't allowed to use L'Hopital's. So I think there's a change of variables, and you can make it match the limit definition of a derivative. But I couldn't quite work out what the change of variables is. So yeah, just call that out in case anyone feels like thinking about a fun limit. Okay, but yeah, now let's wrap things up. That's the same as L'Hopital's territory? I didn't know that. Teach me de Moivre's theorem in trig. No? I think of that. I guess de Moivre's might have to do with trig too, but all I know about de Moivre's theorem is the statement of the formula. I don't know anything else about it. Oh, that's cool, territory. I've never seen a proof for L'Hopital's. I would look it up, but I'm getting really hungry, so that'll be another time. Okay. Anyway, I'm gonna cut the YouTube stream off here and then look for a raid over on Twitch. So Territar, Depayon, anyone else who's here on YouTube, thank you all for being here. What's my height? I'm 5 feet 11 inches. I'll let you convert that to centimeters if you prefer those. So yeah, anyways here on YouTube, thanks. I plan to be back on Thursday. So see y'all later.